method of differentiation. Now, we have three basic methods of differentiation. The first one is chain rule. The second one is product rule. And the third one is quotient rule. So we are going to look into these rules one after the other. For the meantime, chain rule. When we have a composite function, a function that is contained in another function, when you're asked to find the derivative, the method you use is what? Chain rule. We'll first of all identify the type of function that is given. If this function is product functions, like you have two different functions, for example, exponential, something like this, dot sign x, we apply product rule. If you have a rational function like this, sin x over cos x, we apply quotient rule. So in this video, I'm going to teach you how to apply this chain rule, product rule, and quotient rule. I would like you to follow this from beginning to the end. Okay? And subscribe, like, and comment, so you always get the video update. Now, let's pick the first one, chain rule. If you have a function like this, y is equal to f of x. Y is equal to f of x. Y is a function of x. Then we say, let u be another function of x. That is, this x is also a function. Therefore, we say dy dx is what we are looking for. Here we have y is equal to f of u. This x is a function of x, that is g of x. We say let it be u. Anywhere you see x, replace it with g of x, which is u. So we have u here. Now to get dy dx, we differentiate u with respect to x. Here we have du dx. We differentiate y with respect to u. So chain rule therefore is dy dx is equal to dy du times du dx. So this is dy dx, the derivative of a composite function, a function that is contained in another function, function of functions. Okay, so this is dy dx, which is our chain rule. We apply this rule to every function that is a composite function. A composite function is a function that is contained in another function. When you see a question like this, don't panic. First, observe and identify the question. This question is a composite function. As it stands, it's just like a function that has two functions. This x squared plus 3 is a function. Then all raised to the power 5. Okay? And we call the inner function u. Which is u equal to x squared plus 3. And we say y equal to u raised to the power 5. Again, from chain rule, we have dy dx is equal to dy du times du dx. So from here, we can easily say differentiate u with respect to x. We have 2x. If you differentiate 3, we have 0, it's gone. Differentiate y with respect to u. We have 5u4. So you join them together, applying this rule. dy dx is equal to dy du is 5u raised to the power 4 multiplied by du dx is 2x. So that 2x times 5 will give us 10x u4. But what is u? 10x, u is x squared plus 3. X squared plus 3, all raised to the power 4. Have you seen it? Very simple. What your professor didn't teach you in secondary school, in the lecture hall. We write dy dx equal to differentiate inside. So when you differentiate x squared, you have 2x. Differentiate 3, you have 0. So 2x multiplied by 5 will give you 10x. So you reduce the power. You reduce the power. 5 minus 1, which is 4. Beautiful. That is the answer. Especially if you're preparing for an objective question exam. This is how you can solve it without stressing yourself. I'm so sure that chain rule is done and dusted. Now, there are other questions that could come up under chain rule, which you might find so difficult. But the first thing is identify that this particular question is a composite function. When you observe the types of function you are saying, we'll be able to solve it. Apply the actual formula. Now, square root of x plus 4. This is also a composite function. We already have that y is equal to root x. This is an irrational function. And for an irrational function, root of any number is solved. And we already know that y is the same thing as x raised to the power 1 over 2. When you solve this, dy dx will give us 1 over 2, bring it down, multiply by x. 1 over 2 minus 1. So this is going to give us 1 over 2 multiplied by half minus 1 is minus half. So we have x minus half. Okay, so from here, you'll find out that dy dx is going to be 1 over 2, 1 over x1 over 2, so that dy dx will be 1 times 1, 1 over 2 square root of x. So anytime you are given y equal to root x, the answer is 1 over 2 root x. Now, y is equal to root x. Dy dx is equal to 1 all over 2 root x. Y is equal to root x plus 4. So what is dy dx? How do we solve this? Very simple. You see, here is x and here is x plus 4. All you just need to do, we apply this method. If this is sod x, here is sod x plus 4, this is dy dx of it. You take the structure, which is what? 1 over 2 sod x plus 4. Have you seen it? Then you now come inside. Since this one is composite function, but this is not a composite function, you now differentiate inside. That thing, that function that made it to be a composite function, you differentiate it. It's when you differentiate it, you now understand that whatsoever you get, you put it at the numerator. So differentiate x plus 4, you get 1. So 1 times 1 is 1. So our answer is this. However, you can have a function like y is equal to square root of x squared minus 5. The answer is dy dx is equal to 1 over 2 sod x squared minus 5. Now, this is a composite function as well. We are applying chain rule. But as you can see, we have solved 1, 2, 3 questions without actually using chain rule. Now, differentiate x squared. You have 2x. Differentiate 5. You have 0. Differentiate x squared. You have 2x. Differentiate 5 minus 5. You have 0. So 2x, you place it at the numerator. And that is the answer. This cancel out this. So your final answer for this question, dy dx, is equal to x over square root of x squared minus 5. And life is easy. And who says mathematics is difficult? Subscribe for more videos. Now, the next is product rule. Product rule has y equal to u dot v as two functions that are multiplying themselves. Let u be a function with respect to x, and that u v a function with respect to x. So how can we differentiate this type of a function? That is what you also have to apply product rule. For example, we say the y dx is equal to, you keep one constant, differentiate the other. Keep u constant, differentiate v with respect to x, plus keep v constant, differentiate u with respect to x. And that is product rule. Very simple. No stress. Now, we pick a question, x squared sine x. When you are asked to find the y dx, this is product function. We have x squared power function, we have sine x trigonometric function. So they are multiplying each other, so we need to apply product rule. And what should we do? Let u be x squared, v sine x. So this is u, this is v. So applying the same rule, the y ds is equal to u is kept constant. So we keep x squared constant. Differentiating sine x, we get cos x. So if you differentiate sine x, we get cos x. Plus, this is v, and this is v sine x. You keep it constant. You keep it constant. Then differentiate x squared. You have 2x. Okay? So you rearrange it and write x squared plus x plus 2x sine x. And that is all. That is all. In our next video, we shall talk about quotient rule.